So let's talk about one of the biggest, most frustrating problems in AI right now, based on some really fascinating new research. Why in the world do language models just make things up?
You've probably seen this happen. You ask an AI a question, and it spits out an answer that sounds totally legit, but it's completely wrong. So what is going on here? How can these super smart, powerful systems just confidently invent facts out of thin air?
Okay, check out this wild example, straight from the research paper itself. One of the authors, a guy named Adam Kalai, asked a few AIs for the title of his own dissertation. On the left, that's the right answer. But look at what DeepSeek and Llama came up with. They invented totally different titles, different years, even different universities. I mean, they're not just a little off, they're inventing whole new realities.
This whole thing has a name. You've probably heard it, hallucinations. And they aren't just random nonsense. They are plausible falsehoods, which is what makes them so tricky. And that's a massive problem, right? Because if you can't actually trust the answers you're getting, the whole thing kind of falls apart.
Now you might be thinking, okay, it's just a bug, they'll patch it. But according to this paper, it's not that simple. It's actually a deeper two-part mystery. The answer lies in two key clues, one about how these AIs are born, and the other in how we grade them.
All right, let's play detective. It's time to dig into our first clue, and this takes us all the way back to how an AI is first trained. It turns out the seeds of these hallucinations are planted right from the very beginning.
The paper boils it all down to a fundamental statistical problem they call the is it valid problem. Basically, when an AI is learning, deep down it's just trying to figure out a simple binary choice for everything it sees. Is this statement valid or is it an error? It's like a giant galaxy-sized game of true or false.
So the model gets fed just a ton of examples. Some are easy, like spotting a spelling mistake. Greetings is good, greetings is bad. Some are simple facts. There are 2 Ds in ladder, got it. But then it gets these random, arbitrary facts, like birthdays, that don't really follow any neat pattern.
And this is the absolute kicker. If the model can't figure out a perfect, foolproof rule to separate every valid statement from every possible error, it's not just likely to make mistakes. It is statistically guaranteed to generate errors. Hallucinations aren't a bug, they're a feature of the math. And to put a number on it, the paper gives this really clear example. Imagine 20% of the birthday facts in its training data only show up one time, while the theory says the model is basically forced to hallucinate on at least 20% of birthday-related questions. The less data it has, the more it's going to make stuff up.
Okay, so we know the model is basically built to make some mistakes. But why don't we just train that out of it later? Well, that leads us to our second clue. And honestly, this part is kind of wild. It turns out we're actually rewarding the models for this bad behavior.
This quote from the paper just nails it. Think about it. An AI is basically trained to be a really, really good test taker. And if you're taking a test where there's no penalty for a wrong answer, what's your best strategy when you're not sure? You guess. AIs are built to ace their exams, and right now, guessing is the best way to do it. So that begs the obvious question, right? How exactly are we grading these AI students? Let's take a look at the tests we're actually giving them.
Take a look at this. These are some of the biggest, most important AI benchmarks. Think of them like the SATs for the AI world. And you see the pattern here, right? They're all graded on a simple right or wrong basis. Yes? And how much credit do they get for just admitting, I don't know? None. Zero. A big old nothing.
The paper has a great name for this, an epidemic of penalizing uncertainty. We've accidentally created a system where the smartest move for any AI is to just give a confident-sounding answer, even if it has to pull it out of thin air. It gets 0 points for being honest, but it has a shot at full credit for a lucky guess.
So, we've got our 2 clues. Let's put it all together, solve this mystery, and then, most importantly, look at what the researchers think we should do about it.
So here it is, the mystery solved. It's a 1-2 punch. First, the very way these models are born, their pre-training, statistically forces them to generate errors. And second, the way we test them afterwards actually rewards them for confidently guessing instead of admitting they don't know.
So how do we fix this whole mess? Well, it's all about changing the incentives, changing the rules of the game. We need to shift from a system where guessing is always the winning move to a new system where saying I don't know is actually a safe and sometimes the best option.
And this isn't just some abstract idea. They give a really concrete example of how you could change a test prompt. Imagine if the instructions said this. All of a sudden, the whole calculation changes, right? Guessing becomes super risky. Being honest about your uncertainty, that's now the smart play. And this is so important. The paper's big takeaway isn't that we need to invent a bunch of new, complicated tests. Nope. It's that we need to change the rules of the big, influential benchmarks that everyone in the field is already obsessed with. That's how you shift the incentives for everybody.
Which really leaves us with this one big thought to chew on. After all the incredible complexity and brain power that goes into building AI, maybe the very first step toward making it truly trustworthy is just teaching it something incredibly simple, something very human. How to say, I don't know. A pretty fascinating idea to think about. Thanks for tuning in.